Hello, everyone, and welcome. Today we're diving into one of the most powerful tools in artificial intelligence, machine learning, and even our everyday lives, Bayesian networks. Don't worry, I'll break it all down in a super simple, beginner-friendly way. Let's get started. So what are we talking about when we say Bayesian network? Think of it as a smart map that shows how different things in the world are connected, especially when there's a lot of uncertainty. In real life, we deal with uncertainty all the time. Will it rain later? Will I get to the office on time? Is this investment risky? Bayesian networks help us answer these kinds of questions using the power of probability. Let's break down what a Bayesian network is made of. It has two main parts. First, we have nodes. These are just circles or boxes that represent variables, anything you want to measure or understand. This could be the weather, traffic, a person's age, or their income. Second, we have directed arrows, also known as edges. These arrows show how one variable influences another. For example, an arrow from rain to traffic means that rain affects traffic. Together, these nodes and arrows create what's called a directed acyclic graph, or DAG. That's just a fancy way of saying the arrows always point forward and never loop back on themselves. So a Bayesian network is simply variables, plus their connections, plus probabilities. Let's use a really easy example to see this in action. Imagine three variables: rain, traffic, and being late to work. Now let's think about how they relate to each other. If it rains, there's a higher chance of heavy traffic, right? And if there's heavy traffic, you have a higher chance of being late. We can draw this as a simple chain. Rain leads to traffic, which leads to being late. This little chain is a basic Bayesian network. Here's where it gets powerful. Let's say you wake up and see that it's raining. The network can use this information to calculate the probability of heavy traffic. From that, it can then calculate the probability of you being late. But what's really cool is that it works in reverse, too. If you're stuck in heavy traffic but don't know the weather, the model can estimate the probability that it's raining. This ability to reason both forwards and backwards is what makes these networks so special. So, how does it do all this math? Every node in the network has something called a conditional probability table, or CPT. This table basically lists the probabilities for that variable based on its parent nodes. For our example, the traffic node would have a table that answers questions like, what's the probability of traffic being high if it's raining? What about if it's not raining? These probabilities are the engine of the network. When new information comes in, like knowing it's raining, the network uses these tables to update its predictions. This process of making predictions is called inference. Because they are so good at handling uncertainty, Bayesian networks are used everywhere. In medicine, doctors and AI systems use them to diagnose diseases by looking at symptoms and test results. In machine learning, self-driving cars use them to predict risks on the road, and recommendation engines use them to figure out what you might like next. In finance, banks use them to decide if a loan is safe to approve or to detect fraudulent transactions. Even weather forecasting models use Bayesian methods to combine different uncertain data points to predict storms and temperature changes. You might be wondering, why are they called Bayesian? They're named after Bayes' theorem, a famous mathematical formula. The core idea of this theorem is about updating your beliefs when you get new evidence. Think of it like this. Your new belief is equal to your old belief multiplied by the strength of the new evidence. For example, you might start the day thinking there's a small chance of rain, but then you look outside and see dark, heavy clouds. You instantly update your belief and think rain is much more likely. That's exactly what Bayesian networks do, but with precise mathematics. They continuously learn and adjust their predictions as more information becomes available. So let's quickly recap. A Bayesian network is a graph made of nodes and arrows. The nodes are variables, and the arrows show how they influence each other. Each node has a probability table that guides its behavior. This structure allows the model to make powerful predictions even when information is incomplete. They're a cornerstone of modern AI, medicine, finance, and many other fields, all thanks to their ability to update beliefs based on new evidence, just like our brains do, and that's a complete, easy-to-understand explanation of Bayesian networks. I hope this video made this complex topic feel a lot simpler. If you found this helpful, please give it a thumbs up and don't forget to subscribe for more content like this. Thanks for watching, and I'll see you in the next one.